The skeletal system, part 1. The skeletal system has 5 main functions. It provides shape and support, enables movement, provides protection of internal organs, produces blood cells, and finally, provides storage of minerals such as calcium and phosphorus. The skeletal and muscular systems work together. They allow body movement. Bone attaches to bone via ligaments. Muscles attach to bone via tendons, and movement occurs when the muscles pulls on the bones or joints. And the skeleton provides the structure, whereas the muscles themselves provide the mobility. The human skeleton itself is made up of 206 bones total, and it's divided into 2 parts. The first part is the axial skeleton. The axial skeleton contains 80 bones. It makes up what is considered the central axis of the body and includes the skull, ribs, spine, sternum, vertebrae, and the hyoid or the jaw. The appendicular skeleton has the other 126 bones. It makes up the limbs hanging off of the axial skeleton. It includes both the upper and lower extremities, the pelvic girdle, and the phalanges. Here's a picture illustrating that. Axial skeleton again making up that central axis, and the appendicular skeleton containing the limbs that hang off the central axis. The skeletal system itself is made up of 3 main parts. The bones. The bones are the strong living tissue with 206 in total. Most of the mass of the bones consists of non-living extracellular crystals of calcium minerals, and that's what gives bones their hard, rigid appearance and feel. The cartilage is the tissue that's more flexible than bone. It contains fibers of collagen and elastin. And finally, the third part is the ligaments. The ligaments are what attaches bone to bone and helps to hold the bone in place. There are 5 main types of bones. They come in lots of different shapes and sizes, and the categories are based on their shape. You have long bones, and I'm going to go through each one of these. Short bones, flat bones, and irregular bones. Finally, the last one is the sesamoid bones. Here's just an illustration. So long bones, we have both the femur, the ulna, the radius. Short bones, you have the talus, which is in the ankle, and the carpal bones, which make up the fingers as examples. Flat bones would be the sternum and the scapula. Irregular bones including the sphenoid, which is found in the skull and the vertebrae. Long bones are considered long bones when they are longer than they are wide. They also work as levers. They have a shaft with 2 ends, and they typically will provide strength and structure and help with movement. Examples of long bones are the bones that make up the arms and the legs. Short bones are actually short and tend to be cube shape. These would be the bones you would find in the ankles and the wrist. Flat bones are thin and flat with a broad surface that often has a curve to it. They're used to protect organs and attach wide muscles. Examples of these would be the sternum, scapula, ribs, and skull. Irregular bones are the ones that you can't fit them into other categories because of their shape. They come in a wide variety of shapes and sizes, and examples are hip bones, vertebrae, and middle ear bones. The last one, the sesamoid bones, these are short bones that are found within tendons. The patella or the kneecap is actually the largest one. Bones are complex living structures. They are one of the strongest tissues in the human body, and what's cool is they are also one of the lightest. They're made up of 5 materials, and I will quickly go over each one of these. You have the periosteum, the compact bone, spongy bone, bone marrow, and also the cartilage. You get a good example of that by looking at a cross-section of a long bone. The long bone, just as a note, you have the epiphyseus, which is the enlarged head at the either end of the bone, and the diaphysis, which is the shaft in the middle. The periosteum is the outer surface of the bone that's surrounded by a double membrane. It covers the surface of the bone except at the joints, and that's where you would have cartilage, and it supplies the blood vessels and nerves to the bone. Compact bone accounts for about 80% of the bone mass. It's the hard outer layer. But remember, one thing that's interesting to know, I don't know about remember, is that bones have a hard outer layer, but in fact inside they're not solid. The compact bone is the part that provides the strength and protection, and it also gives bones their smooth, white, and solid appearance. Spongy bone has many air pockets that create a very light yet strong structure. They account for about 20% of the mass of bone. They're found at the ends of long bones or the centers of short, flat bones. They are less dense than compact bone, and they have a lot of cavities that are filled with bone marrow, and this makes the spongy bone, makes bones in general very light and strong. The bone marrow is also called myeloid tissue. It's a soft gelatinous tissue that fills cavities. There comes in two different types, red or yellow, and that will depend on how much red or fatty tissue is present within that. A little bit more on that bone marrow. Red bone marrow produces red blood cells, white blood cells, and platelets in a process that's called hemoptysis. The process is called hemopoiesis. It helps the body with everyday functions by producing those red blood cells. Interestingly, when in children, almost every bone is filled exclusively with red marrow. It's found in the flat bones of the skull, vertebrae, sternum, ribs, shoulder blades, and pelvis. Yellow bone marrow produces fat cells. It helps the body survive extreme cases of hunger and or blood loss by serving as an energy reserve. With age, half of the red bone marrow is actually replaced with yellow marrow. It's found in the hollow interior of long bones, such as in the arms and legs. Here is an example picture looking at, just to orient you, you've got the compact bone on the outside, and within that spongy bone you have red marrow, and then even in the shaft of it, then you can see there is yellow marrow. And there's just another way to look at an actual picture instead of a drawing. Another part of bone is the cartilage. The cartilage is a tough, flexible, and slippery type of connective tissue. It's actually mostly water, and it doesn't contain any blood vessels or nerves. It's found at the ends of bones where they meet other bones. It acts to reduce friction and act as a shock absorber. It also contains the growth plates in children, which I'll talk more about in just a second. One thing about cartilage, though, is it actually heals very poorly and slowly when injured. Bone growth actually starts to begin in the growing embryo. By the end of the 8th week after conception, the skeletal pattern has been created in all cartilage. Ossification, which is another term for bone development, begins over this cartilage base and replaces it. Long bones will then develop locations for new growth, either at the end of either end of the bone shaft. Between the developing bone and the ossified bone, and again, ossified means the developing new bone, there is a layer of cartilage that's called the growth plate, which is also named the epiphyseal plate. The growth plate moves steadily away from the bone towards the end until all the cartilage is ossified, which typically happens in the early 20s. We're going to move on and talk a little bit about joints next. A joint is a place where two bones meet. It allows the bones to move in different ways, and there are two main types of joints. Those movable joints, those allow a range of motion. We call them synovial, and also immovable joints. And these joints allow little or no movement, and they are called synarthrosis. Again, these types of joint is where two or more bones fuse together. Classic example is the skull sutures. So you've got different bones that make up the skull, and where those different bones meet are immovable. Synovial joints, these are where bones meet. The surfaces tend to be covered with a particular type of cartilage. These allow tendons and ligaments to stabilize the joint. They contain a joint cavity, and in that joint cavity there's a fluid called synovial fluid that acts as a lubrication. And there's also a synovial membrane or joint capsule that covers the joint, followed by some sensory neurons and blood vessels. So these are all the things that you would find in a movable joint. You can see here a structure of a joint. You've got the cartilage between where the two bones meet, the tendons that's attaching the bones, and the ligament that's attaching, tendons that are attaching the muscle to the bone, and the ligaments attaching bone to bone. Because bones will rub against each other at joints, cartilage helps to reduce the friction between those bones. It covers the ends of bones at joints and acts as a cushion to keep that movement smooth. Bones have to be held together at joints, and ligaments are strong bands of rope-like tissue that holds the bones in place. Ligaments connect bone to bone and they keep them from slipping out of joint. Tendons are what connects muscles to bone. They are rope-like bands of tissue that pull on the bones at joints, and these are what allow you to move your body. There are 6 different types of synovial joints. Ball and socket, these are named for the function that they do. Saddle, ellipsoid, pivot, hinge, and plane. Movement at synovial joints can take a few different forms. You can have flexion, extension, hyperextension, abduction, adduction, and also circumduction. Flexion will decrease the angle between 2 body parts. Extension increases the angle between 2 body parts. Hyperextension of a limb is extension beyond its normal limit. Abduction is movement away from the midline. Adduction is movement towards the midline. And circumduction is more of a circular movement away from a joint. So here's just some illustrations to go through those again. Flexion decreasing, extension increasing, hyperextension more than normal, abduction moving away from the midline, adduction moving towards the midline, and circumduction in a circular motion. Ball and socket joints permit the movement around several axes, and they provide the widest range of movement. This is in the shoulder and the hip. A pivot joint allows rotation from one bone around another, like in the neck and lower arm. The saddle joint allows 2-directional movement, like in the thumb. Hinge joint permits flexion and extension, like the elbow and the knee. Ellipsoid joint allows for side to side and back and forth motion, like the bones in the wrist. And finally, the plane joint permits gliding motion, like vertebrae, and also some bones within the hands and feet. The final section was a quick overview of some problems associated with the skeletal system. One is fractures. There are a lot of different types of fractures, and they are named for how the bone breaks. The top 5 broken bones are clavicle, which is usually broken in falls, arm, including the radius, ulna, or humerus. Wrist bones, this is because the wrist absorbs so much force when we instinctively will put our hands out to break a fall. Hip bone, most common bone in people over 65 to break. Women actually have the highest risk due to calcium loss after menopause. And finally, the ankle bone, which are typically broken because the ankles are twisted too far. Other types of skeletal injuries are sprains. Sprains occur when ligaments that reinforce the joint are stretched or torn. Partially torn ligaments repair themselves very slowly, and this is why sometimes sprains can cause a lot more problems than a break. Dislocations are when bones in a joint are forced out of alignment, typically caused by big falls and sports injuries. A dislocation will usually include a sprain and also a lot of inflammation and loss of mobility around the joint. Finally, there's cartilage injuries. That's when the cartilage at joints becomes overstressed. They can actually snap or break and be worn down, and these are usually repaired by arthroscopic surgery. Here's just some examples of sprains, dislocations, and cartilage injuries. There are also some disorders that are associated with the skeletal system. Spinal stenosis is the narrowing of a spinal column. Achondroplasia, which is dwarfism. This is a defect in the cartilage at growth plates of long bones. There's osteoporosis, which is when the creation of new bone doesn't match the loss of old bone. It makes bones much more susceptible to fractures. And scoliosis, which is the lateral curve of the spine. Bursitis, it's also called bursa inflammation. This is inflammation at the fluid-filled pads that act as cushions at joints, typically associated with pain, swelling, and stiffness. Tendinitis is a condition where the tissue connecting muscle to bone becomes inflamed. Typically, this happens in athletes that use their joints a lot. They'll experience some tendinitis. Arthritis is also a joint inflammation. This inflammation at one or more joints causing pain and stiffness that actually typically gets worse with age. There are different types: osteoarthritis, rheumatoid arthritis, juvenile rheumatoid arthritis, and also gouty arthritis. Osteoarthritis occurs when flexible tissue or the cartilage at the end of the bone becomes worn down. This is the most common type of arthritis. Rheumatoid arthritis is chronic inflammatory autoimmune disease of an unknown cause and usually arises between ages of 40 or 50, but can occur at any age. Gout is a form of arthritis caused by severe pain, redness, and tenderness in joints. It's due to uric acid crystals that are deposited within the joints, and it's typically experienced at the joint at the base of the big toe. And that will do it for the skeletal system.